Hello students, most welcome to Dr. Achire Academy. Today I am going to discuss the limitations of the octet rule. In the previous class, I discussed about the application of the octet rules, how to apply in the Lewis structure of different molecules. Today's class is on the limitations of the octet rule. This topic has been taken from the NCERT Chemistry Class 11 books. This is the unit number 4. Today's class number is 070. Octet rule, though it is very useful, but it is not universal. It is quite useful for understanding the structures of most of the organic compounds, and it applies mainly to the second period elements of the periodic table. In the second period elements of periodic table, it starts from the group 1, lithium element, and extreme right side group 18 is the neon, and group 17 is fluorine. So this octet rule mainly is useful for the molecule related to the second period of elements of the periodic table. There are three types of exceptions to the octet rule. Number 1, the incomplete octet of the central atom. In some compounds, the number of electrons surrounding the central atom is less than 8. This is especially the case with elements having less than 4 valence electrons. We'll give example. Example is LiCl, lithium chloride, hydride of beryllium, BH2, and chloride of boron, BCl3. So here we know, I told that this deviation of the octet rule applies to those elements which have less than 4 valence electrons. So in this case, you see lithium, its valence electron is 1, that means less than 4 valence electrons, whatever I already discussed. For beryllium also it is the 2, and for boron valence electron is 3. So all these 3 elements, lithium, beryllium, boron, has less than 4 valence electrons. Some other such compounds are chloride of aluminium, AlCl3, and fluoride of boron, BF3. Odd electron molecules, that means in molecules with an odd order of electrons like nitric oxide, NO, and nitrogen dioxide, NO2. The octet rule in these molecules is not satisfied related to the atoms, that means nitrogen and oxygen, for both nitric oxide and nitrogen dioxide. You can see here, left side nitrogen, it has double bond, that means shared 4 number of electrons, and lone pair, one pair. So 4, 6 and 7. That means this nitrogen has less than 8 electrons, which is the deviation from the octet rule. But right side oxygen, you can see this fulfill the octet rule because 2 lone pairs is there and 1 double bond is there. That means 8 electrons is shared and occupied by this oxygen atom. And if you see this right side, the nitrogen dioxide, then you can see that left side oxygen, it fulfills the octet rule because it has 1 double bond and 2 lone pairs. That means 8 electrons. But middle nitrogen, if you see, it has 1 double bond. That means 4 number electrons, 1 single bond. That means 2 number of electrons, total 6, and 1 single electron above the nitrogen. So total number of electrons of nitrogen is 7, and 1 plus charge is there. So these 7 electrons with this nitrogen atom, and it is also deviation from the octet rule because this atom doesn't have 8 electrons. And right side, if you see that oxygen atom, it fulfills the octet rule because it has the 3 number of lone pairs, that is 6 electrons, and 1 single bond, that means 2 number of electrons, total 8 number of electrons which fulfill the octet rule. So in both compound, oxide and nitrogen dioxide, that nitrogen is deviate from octet rule. Now I'll discuss about the expanded octet. That means the atom will have more than 8 electrons. The elements in and beyond the third period of the periodic table. Third period means it starts with the sodium and it ends with the group 17 elements, chlorine, and group 18 is the argon elements. So elements in and beyond the third period of the periodic table have, apart from 3s and 3p orbitals, it has d orbitals which is available for bonding. And that is the reason it can expand beyond the octet rules. That means it can have more than 8 electrons in its valence shell. The number of compounds of these elements, there are more than 8 valence electrons around the central atom, and that's why it's called the expanded octet rule. And this is termed as the expanded octet. So what is expanded octet? In a number of compounds of the elements belongs to the third period. These compounds atom may have more than 8 valence electrons, and this fact is termed as the expanded octet. And in this case also the octet rule does not apply. Some of the examples of the compound is the PF5, SF6, H2SO4, and a number of coordination compounds. Why it is happening? Because the atoms of these elements have 3d orbitals in addition to the 3s and 3p orbitals. So some examples, you can see the structure here. If you consider this phosphorus atom, so it has the 5 number of single bonds. 5 number of single bonds means 10 number of electrons around the phosphorus atom. In the second case, SF6, if you see this Lewis dot structure, and you can see that sulfur has 1, 2, 3, 4, 5, 6 number of single bonds. Each single bond contains 2 electrons, so 6 number of electrons is got 12 number of electrons around this sulfur atom. On the extreme right, we'll consider the sulfur atom in the sulfuric acid H2SO4. So if you see the structure, you see this sulfur has 2 number of double bonds and 2 numbers of single bond. So double bond means 4 electrons. This is 2 double bond means 4, 4, 8 electrons, and 2 number of single bonds means 2 plus 2, 4 electrons. So here 4 electrons, down 4 electrons, inside 2 electrons, that is 10, and left side 2 electrons, 12. So 12 number of electrons around the sulfur atom. So this is the expanded octet formation. But one thing you have to remember, sulfur also forms many compounds in which the octet rule is obeyed. That means for sulfur atom, it may follow octet rule or it may not follow the octet rule. Example, or it follow the octet rule, sulfur dichloride. Down you see, this is a sulfur, it has 2 lone pairs, that means 4 electrons, and 2 single bonds left side right side with chlorine. So this is also 2 plus 2, 4 number of electrons. So sulfur has 8 number of electrons, which follows the octet rule. Other drawbacks of the octet theory. It is clear that the octet rule is based upon the chemical inertness of the noble gas. In the previous class, I already discussed on it. Octet rule is followed due to the fact that the atoms during the formation of the molecules want to create the electronic configuration of noble gas, which is chemically inert. Some noble gas, for example, xenon and krypton, also combine with oxygen and fluorine to form a number of compounds. And this is also other drawback of the octet theory, as for example, XeF2, KrF2, XeOF2, etc. That means generally noble gas do not form any chemical compounds because this atom already has 8 electrons, but there is some deviation, which is the drawback of the octet theory. The drawback, this theory does not account for the shape of molecules. This theory is not related to count the shape of molecules. This theory does not explain the relative stability of the molecules, being totally silent about the energy of a molecule. So this octet theory is unable to explain the relative stability of the molecules. I hope that you understand the drawbacks of the octet rule very clearly, and what is the expanded octet. I also explain in an easy way. I have the podcast for higher level honors and degree level chemistry education. You can go through this. Thank you so much for watching this class.